In this tutorial, I'm going to create a low poly rubber duck using the Blender Python API and then display it in the website with very little coding. Alright, so before we begin, quick reminder, I do a live stream every single day at 2 p.m. Eastern. You're free to join and post any programming or lifestyle topics in the live chat. And also be sure to subscribe, like, follow, and leave comments for more frequent content. As you can see in my hands, I do have goosebumps because it's 20 degrees today. As you know, the entire summer has been extremely hot, and today is just a cool day, but hopefully it doesn't rain. I'll go outside and finish up the shed. All right. So this rubber duck, as I said, we're gonna create it using Python. So we don't need to use Blender. We don't have to open up Blender using the GUI. Obviously, you didn't have Blender installed because we're going to run it from the command line in the background. And to display it on the website, we're going to use something called the model viewer. I'll explain that when we get to it. So essentially, the code, the command line we use is Blender, then space, hyphen, background, space, hyphen, Python, all lowercase, space, and then obviously the name of the Python file. And this runs Blender without the graphical interface, executes your script, and you can export the model directly in the script as a GLTF file. The GLTF is JSON, basically a text file by default. However, when you have lots of stuff going on, especially procedural textures, a lot of nodes, you can use the GLB, that's a binary version. So obviously it will be just a better way to manage your assets, and you don't have to worry about corruption because it's just one file. All right, and now so if you're impatient, no problem with that. You can simply just expand the source here and then grab the code and just paste it into the Blender. You can open a Blender, paste it into the scripting workspace, and then it will automatically create the file for you to export the GLB file for you. It is going to be relative to where the Python file is. So let's actually get started here. What you're going to see is this is the Python code. So as usual, your first thing you always need to do is import the Python module. So the Blender Python module, this is the one here, it says bpy, that's Blender Python. Yeah, I'm going to use bmesh. This way we don't have to, as I said before, I want to use as less code as possible. So I'm going to use a bmesh. And then we're going to import math. This just makes our code also simpler. And I'll explain to you that when we where we use actually math. The OS, that's the operating system. The reason I'm importing this is because, remember I said I want it to be relative to where the Python file is. That's why I want to save everything. It's just easier. So you can see here I'll create a special folder. So when I save everything, I want to save the blend file, the GLTF file, this is the binary version of it, and in the same folder. So what I'm going to do is I'm going to actually delete this too, and we will recreate them. So don't worry, it'll be exactly the same. So the first thing we do is we clear all existing objects. The objects are usually there's a light, as at least of 2025 in Blender 4.5 LTS. There's a light, there's a default cube, and there's a camera. We don't need any of them. So that's why we're deleting them. Now the reason that this code is slightly feature-proof is because in the future Blender might decide to add more things or maybe remove some things. So it's always a good idea to clear them, just make your own stuff. So that way you'll be able to control them as well. I've noticed also trying, for example, when I'm trying to use the default cube or default camera, you have to use like 2, 3, 4 lines of code just to grab them. When it's just, I realize I can just make my own, put the size I want, put them in the position I want, instead of grabbing one and then twisting and turning and rotating. So that's another that's another reason why you can just delete everything and just create your own. So the first function we have here is to create a plastic material. So what we're going to do is we're going to pass a name and the color, and then it will be able to create this for us. So remember, I think about 2 weeks ago, one of my subscribers requested a Python object-oriented programming. So this is part of it, in that we can reuse these functions. So we define them and you can reuse them. So this is one way to do it. So you just use define, or that's how Python does it. And then the name is plastic_mat. And then the two arguments we pass in, the name and color, comma separated, of course. So the material, we use that Blender Python module, data.materials.new, and the name is passed in as an argument. The material is going to use nodes. I think now by default it's always set to true, but you never know. Maybe the person's Blender version has, they set it to false. So just do this. It's good to not assume that in the future maybe a Blender will go back to where you have to enable it. So just set it to true. And then the nodes, we are going to have the tree nodes here, and then the links. Then we'll link everything together. You see that in a second. And we'll clear the default nodes because we again want to create our own. So the output node, we're going to shader node output material. Then the BSDF, that's a shader node, BSDF principled. And then for that particular node, the input node, which is the base color, we set the value to the color. Remember, the color is being passed in as an argument. And the roughness, we hard code this one, we set it to 0.2, so it's going to give it a slight glossy. If you notice plastic, the way you can instantly recognize plastic, there's usually a shiny, shiny little gloss. It's kind of like an orb type gloss. That's how we know it's plastic. Not always, of course. For example, this cable here, you can see that's not obviously shiny. It does have a little bit of shine to it, but yeah, that's an easy way to, for example, I think this is that's not shiny. Oh, here's a perfect example. You see this adapter? You see, yeah, that's how you can tell it's plastic. So I'm saying just to mimic it, just to give it just a slight little gloss. That's how it will be plastic. And then of course we link our BSDF output to the output input surface node, and that's it. And then we return the material. Okay, then we create 3 materials based on that method we just used. So the first one is we're going to create the dark body material. So we pass in these colors, yellow basically, and then we need the beak. The beak is also going to, but the beak is going to be slightly, it's going to be orange. So that's why we pass in the orange color, and then the black, that's going to be for the eye color. So we just pass in black. Now you might be wondering, wait a minute, this doesn't look like RGB. Remember, Blender, they use Radeon, so basically that means the values can't be greater than 1. So if you're using RGB, there's 2 versions of RGB. You can do 128 or 256. So sorry, 255. Really, it's 256, but because you're starting at 0, so 0 to 255. And obviously the 128, you get this. It's the same thing. So just make sure you divide it by 1 if you're using the 255 to represent white, or if you're using the 128, do the same thing, and then that's how you will know. So for example, this black here, it's 0. You might say, why isn't this 0000? Well, it's because I don't want it to be like completely black. It's just off, but it's close enough to black. It is still black. This will still be considered black. Okay, then we're going to create a UV sphere. So this UV sphere is what we're going to use, because remember, we're going to reuse this function multiple times. Remember, eyes are round. Think about it. Eyes are round. The head will be, the head will also be round. So instead of creating multiple steps, that's why we use functions. So in this case, I just go and add UV sphere. So we get the name, the location, the scale, and the material. Remember, we've already created the materials here. So what you do is we use the Blender module again, the Python one. We mesh primitive, UV sphere add. The segment will be 32. Remember, we're making low poly, low. And then the ring count will be 16, radius is 1, location will be the argument passed in. The context, we make it the active object. and the name will be the name that passed in the argument. The scale again passed in the argument, and then the materials. Remember, the material will be passed in there, and then all we do is we set it to shade smooth, and then we return that object. And then for the body, now for example, to create the body, because it's going to be roundish, we use that function, this one here I've just made. So for example, the body, we call it duck_body, and we pass in the location, the scale, and its material. If you remember the material, it should be yellow. Yeah, it's the yellow material. Next, we create the head. The head will have the same matte body material, which is yellow, and then obviously it's called duck_head, and then we pass in again. We pass in the same thing. We pass in the location, scale, and the material. And then for the beak is slightly the beak is slightly different because it's more flat. It's not quite round. So for the beak one, we have to there's actually two of them. There's the upper and lower, basically lips if you want. So what we do is we same thing. We use a UV sphere 32 ring 16, and we hard code the location here. And then we, the name would be duck upper beak. We scale it at specific like this, and then the materials, and we set it shade smooth. And the lower one, you can see it's the same thing except the values change for the location, and the scale slightly changes as well. So this, of course, the material is the same thing. It's the beak, and then the orange one, and then the shade smooth as well. So then we return the upper and lower, and then as you can see here, we say upper_beak, comma lower_beak equals create _duck_beak. So that's a method. So this is another way this is the object-oriented programming. So hopefully that helps. With that as well. And then next we create the eyes. We use our first function, the UV sphere. So left eye, it's called duck_I_L for standing for left, and we pass in the same things again, the location, the scale, and the material, the black color. And the same thing for the right eye, except it's going to be duck_I_R, but we pass in different. Obviously the location is going to be different, and the scale will be exactly the same. Then after that, we need to create some wings again. So we're going to use the same add_UV sphere. So we have a duck_wing for the right and duck_wing for the left, and we just pass in a few different things. Now this is where we need to rotate them. We need to rotate them. So this is where the math comes in. So this is the rotation irregular, and what we do is, you see, we need to use the radians. So instead of saying 25 degrees, it's going to be radians minus 25 on this for the right eye, and for the left eye it's going to be 25. So this 25 is actually degrees, but as I said, Blender uses radians, so that's why we did it this way. Okay, so subdivision for smoothness. So the head, body, head, upper beak, lower beak, the left wing and right wing. We're going to create a new modifier, a subsurface, and they will set the levels to 2 and the render _levels to 2 as well. And now we're done. We need to save. We have a function called save files. Because remember, there's two files we need to save. So the first one will be the script, meaning the the script is obviously the Python script. So we get the current path to the Python script, and also we have that. What we do is we just get the base directory or base folder, and when we do that, we basically just use it to see this one, the blend path. I call it low poly -rubber-duck.blend, and then for the GLB, that's the GLTF binary version. it's low poly hyphen rubber hyphen duck dot glb. So then we can save the blend file. We use the ops.wm.save underscore as underscore main file, and the file path equals blend underscore path. So that will save the blender file. And then we create our glb file where we take the that blender module again, ops.export underscore scene.gltf. Then we set the file path to the glb underscore path, and the export underscore format equals glb, because by default it's just going to be that JSON one, so we want the glb, the binary, and then the export underscore apply equals true, and that's it. And then we can run that function save underscore files. That's it. So that's the code there. Then when you're done, all you need, remember here you see it doesn't exist. So what you do then is just go to the command line, you type blender, just this line right here, blender underscore hyphen hyphen, then you type background. I'm going to use the short form, which is simply hyphen B, and then you can space, then you put hyphen hyphen, and you type Python. I'm going to use the short form, which is hyphen, then capital P, up, and then space, and then the name of the file. So my name of the file is low poly hyphen rubber hyphen duck dot py. Okay, so I'm going to run this, and you can see here I'm using Blender 4.15. You see it's done just like that, just like that. So you see it created the glb file, this one here, and it also created the blend file. So we'll take a look at this in a second. Hold on. Let's finish up the rest of the code. So we also have this low poly rubber duck.html. Don't worry, this is going to take it won't take too long. I'll zoom in here. So just HTML doc type, and we have the viewport here. I set the scale to 1. That way you can open up in any other device, especially your phone. It works as well. I give it a title, and the script, this is the important part. So it's a module, so you can load it, and I use the CDN, so I don't have to download or compile it myself. I just use the CDN. I'm using unpark.com. They're not the sponsor of this video. That's the one I just chose to use. I have some basic styling. You don't actually need this, but I just set up some styling here, so I'm just going to ignore it because it's not necessary. This is not a styling tutorial. And I just gave an h1 tag here called low poly rubber duck model, and then the model viewer. This is the reason we're here today. This is how you're able to view it in the web browser. So it's a model viewer. The model hyphen viewer, that's a tag. The source is set to low poly hyphen rubber hyphen duck dot glb, and then alt tag just set low poly rubber duck. And then this is another one, auto rotate, so it will auto rotate by itself without you doing anything. There's camera control, so you can control it as well. I'll show you that. And then if you have an AR, if you have one of those sets, you can see it. You'll be able to see it in 3D as well. And the shadow intensity, I always leave it at 1. And you can change that to whatever you want. That's it. So now I'm going to open up this blend file. And if you guys are new here, you will notice something very different when I open up the blend file. You see how quickly that was? That's because I'm now using my new build for AI and Blender. However, the GPU is not connected yet. The reason for that is I don't have the shroud for the GPU yet, the AMD Instinct MI60. It's supposed to arrive today, so I'm guessing it will arrive tonight. Or sometime tomorrow. So when it does that, I most likely won't have time to hook it up. So probably if it arrives tonight, I might hook it up tonight, and then it'll be ready for tomorrow. But I'm saying I want to review it for a while because I want to do some tests and set things up. I should not need to install any drivers. I believe it should work right out of the box. All right, so I'm going to make this a little thinner for all the viewers viewing this in a vertical screen. So you can see here, this is the duck. As you can see, the eyes, the lips, and the head, the body, and the wings. So what we do is let's go to the shading and you can see the difference between. Remember, I'm using the CPU. This is the Ryzen 5 5600 GT. So I'm using the CPU and the integrated integrated graphics, and it's so much better than that GTX 950. Okay, so here we go, which has 2 gigs of VRAM. So if we go to, not scripting, what did I want to go here? I wanted to go to, I wanted to go here to the shading. There we go. You can see, it has a little slight gloss just to accentuate the plastic look and feel. And you can see the eyes and the lips. So this is a low poly one. Obviously, you can make it more fancy if you want. You can see why the lips were orange and then the body was set to a yellow color. And you can see here, you can rotate it. Very nice, huh? Nice and simple. So one thing you might notice is the head is perfectly round or close to perfectly round, and the body is not perfectly round. It's more, a little slightly flat. And then the wings are also even more flat. But remember, we all use the same UV sphere for that. And actually, everything was done with a UV sphere. The only one that was, remember the method, we had to create one just for the lips. That's slightly different. I guess I could have created one because they had also different material. But yeah, you could have probably created the same one, just also, instead of hard coding some stuff, we could have done that as well to use less code. All right, so that's the this is the guy right here, and so I'll show you something. So what I'm going to do is I'm going to open up Blender. I'm going to reopen Blender, just a new Blender with nothing. So Blender, just to show you how well the system is working now without any crashes. Remember before it was crashing. I don't know if it was the CPU. So what I'm going to do is I'm going to go to the scripting workspace. This is the scripting workspace. You see there's nothing here. You click New. And what you do is you go to your code, the Python code. I'm going to copy that and I'm going to paste it in here. And just to show you, I'm going to delete this guys again. They should be recreated. I don't know. I think so. If you delete this, it will recreate them. So if you notice, it's a default cube here. So if I run this, guess what will happen? Where's the run button? Here's the run button. You see, it created it. And for example, if I go to layout, zoom in, you see it's our same little rubber ducky. And of course, to see it, we go to the shading. There we go. You see how smooth that is? You guys remember how every single time when I was doing this, there was always a problem. Even when I was using OBS with the CPU, there was always a little problem. So there we go. That's our guy. And we can also go to the shading. Where's the shading here? Shading workspace. Shading, here we go. And here's our rubber ducky again. So if you might be wondering, hey, wait a minute. How come there's no light? Yes, there's no light because I'm using the HDR. So the HDR is the one that's giving it this nice sheen and making it look pretty, very nice. All right, now that's it. Let's get out of here and let's open up a web browser. So let's see, open up the web browser here. Should be able to just drag and drop this. Oh no, I think I can drag and drop. I believe it's not going to work if I just simply drag and drop. Could be wrong. Let's see. Yeah, it's not going to work because we need to have a server running, if I'm correct. Yeah, it's an error. It's an error message. Yeah, so yeah, it's going to be blocked. So we need to run a server. So that's no problem. Let's go back to the command line. So here we are on the command line, and then all you need to do is run Python or PHP server, any server, it doesn't really matter. So I'm going to use Python because it's a Python tutorial here. So I'm going to use the built-in Python web server. So it's Python space -m space, and then you type HTTP http.server, and then you can put your port number. So I'll use 8000. There we go. See, and then that's where we go. So we come up back to about here, and then all you have to do is very simply just type localhost colon 8000 and then / low poly -rubber -duck .html. So when you do that, you see our guy comes right in, and look at that. I'm not, you see, you can see my hands. So it's rotating by itself because we have the what do you call it? Remember we set the auto rotate, so you see it's rotating all by itself. That's actually pretty funny. Yes, look, if my hands are here, I'm not doing anything, right? It's rotating all by itself. I'm not doing anything. So you can see my hands are here. Okay. So anyway, obviously now I'm moving the mouse, and you can see the mouse is here. So you see you can rotate any way you want, and you can see the underbelly. You can also rotate on the sides. You see it can do many different things. So there you go, nice and simple. I said this is a low poly model. Of course, you can make your models as as elaborate as you want. One of the reasons I've been doing low poly models is because of the limits of my system, but I'll try to do a little bit more fancy stuff now going forward, especially with the textures. So yeah, this is the look I was going for, and yeah, it came out pretty well. The yellow looks really nice. You see the eyes and everything. Of course, you can be more elaborate, but I said I just want to show you simple things you can do. Model stuff in Blender, and then put it and view it on the web. Of course, we can also zoom in and zoom out. See that? You can zoom in and zoom out. Okay, enough of that. Okay, so when you go away, it will start auto rotating it. See, all by itself. I'm not doing anything. All right. So I've provided you with the Python code. I've provided you with the HTML code as well. And I took some screenshots here. As you saw, we were able to you can put the code right into the scripting tab, scripting workspace of Python, of Blender, and this is what it would look like. And actually, I think it looks even better than it looks way better than this. So this was on the old system. I'm blown away with this integrated graphics. Wow, really nice, very nice. And then obviously in the web browser as well. So it's the same. As you see, we're able to achieve the same results. And this is the live stream. So if in the future, if you're coming and reading the article, you'll find the obviously by then the live stream will be over. So if I hit play, for example, and you can see there's a slight delay, but you get the point there. So it's perfectly fine. So I do have some additional learning resources if you want to expand your Python or Blender scripting skills. With my recommended books and courses, I have a Learning Python book. It's available on Amazon, and I also have a Mastering Blender Python API book. The link is in the description for both of them. And I also have a Learning Python course on ojamboshop.com. The link is also in the description. And if you need personalized Python or Blender tutorials, I also offer one-on-one online tutorials for Python programming and Blender scripting. You can reach out if you want a personalized guidance to ojambo.com/contact. Feel free to leave any questions and share your duck creations in the comments. Now, with that said, I am going to quick reminder that there's a live stream every single day at 2 p.m. Eastern. Just go to ojambo.com and you go to the watch menu, then you see the live sub menu. It tell you the topics post-dated topics for this and upcoming tutorials. For example, tomorrow we're going to be using HTML5 rotating cube just with WebGL. Alright, and also be sure to subscribe, like, follow, and leave comments for more frequent content. I'd like to thank everybody who subscribed so far this month. Thanks very much. It inspires me to keep on making tutorials just like this one, just for you. If you have any requests, let me know. I can I can honor those requests. I can work them in my schedule. Okay, with that said, I think I'm gonna checking the live stream chat. I don't see any chat requests. I'm going to end this, and I'll see you guys